Okay, so let's solve this question. Basically, what is that? On analysis, a substance was found to contain this much percentage, that is 54.54 percentage of carbon, and you can see the percentage of H, that is hydrogen, and you can see the percentage of oxygen. Okay, now you have to find the empirical formula as well as molecular formula. Okay, one thing is missing here, that should be there in the question, otherwise we will not be able to solve that particular question, and that is what? Your molar mass. Okay, so just add it, molar mass. Without that you will not be able to solve this particular question. So molar mass is basically what, here we are taking what, 88 gram. Okay, molar mass is what, here 88 gram. All right, so now these type of questions, when you are, when you are dealing with these type of questions, you have to stick with a certain defined procedure, and after that these type of questions will be very easy. Okay, so just I am giving you a defined procedure, you have to follow it, and you will be able to solve these type of questions. Okay, so now the what we are making a table, we are going to make a table. Okay, so first we are writing the name of the element. Okay, so element's name, element, so which element is present here? So it is what, look at this, it is what, your carbon. Carbon is there, carbon. Okay, another one is your what, hydrogen. Another one is your what, hydrogen. Okay, and the last one is what, your oxygen. So you have basically three elements in that particular substance. Okay, so now this is what your, this is your first column. Okay, now we are heading to the second one, that is what, your symbol. Okay, so what is the symbol of those elements? Okay, so how, what is the symbol? So then we have to write what, symbol. Okay, symbol. So symbol for carbon is what, your C, symbol for hydrogen is what, your H, and symbol for oxygen is what, your O. Okay, now next we are going to see the percentage of those elements. Okay, that is your percentage. Okay, so this is what, your another column. So what you have to write, this is what the percentage of these elements. Okay, percentage of elements. So it is what, your in first case it is what, your 54.54. Okay, in the second case it is what, your 9.09, and in the third case you have what, 36.36. Okay, now you have to find what, the, you can say, moles of the element. You have to find the moles of element, and for that you have to use this particular formula, that is what, your percentage of element upon, that is what, your molar mass, percentage of that element upon molar mass. Okay, so I think you know the molar mass of these elements. Okay, so first we know that the molar mass of, what is the molar mass of carbon? So it is what, I'm just writing in the bracket, molar mass is what, 12. For hydrogen is what, it is what, 1, and for oxygen it is what, 16. Okay, so for oxygen it is what, 16. All right, so moles of element will be what, the percentage. What is the percentage here? What is the percentage here? So it is what, 54.54. 54.54 upon what is the molar mass, that is what, 12. Okay, so this particular value will come what, around 4.5, around it, maybe it's an approximate value. Okay, and this is the sign of approximation. Okay, so this is approximately equals to 4.5. 12 into 4, 48, and 12 into 0.5, 6. So 48 plus 6, 9, roundabout it is what, 54. Okay, now then it is what, your 9.09 upon it is what, again 1. All right, so it is again approximately, it is what, equals to 9. And you know, this much approximation you can take in chemistry. Okay, don't worry about that. Okay, so this is what, next one is your 36.36 upon 36.36 upon what, 16. Okay, because 16 is the molar mass of this oxygen. Here it is what, why it is 1, because molar mass of hydrogen is what, 1, and what is 12, because of the molar mass of carbon is what, 12. Okay, so this is what, your, this will come what, 2.25, you can calculate. Okay, as is, again approximately it will come what, 2.25. all right, now the next is what, your simplest molar ratio. This is what, your simplest molar simplest molar ratio. Okay, this is what your simplest molar ratio. All right, so this is what your simplest molar ratio. So how to find simplest molar ratio? It's pretty simple. What, just see these values. Okay, just see these values, and what you have to take the smallest value, just take. So what, this one is the smallest value. Okay, so what you have to do, just divide all the values by these values. Okay, so this will be what, 4.5 upon 2.25. okay, then it is what, 9 upon 2.25, and then it is what, 2.25 upon 2.25. okay, so this value will come what, around, this is what, your 2. all right, and this value will come what, 4, and this value will come what, 1. You're getting this point. After that you have to make one more table, and that is what is simplest whole number molar ratio. Simplest whole number molar ratio. Got the point? So simplest whole number molar ratio, what you have to do, simple, just see these numbers. Okay, you have to find one number. Okay, you have to find one number. By multiplying that number, these all becomes what, and that must be the smallest number. Okay, that must be the smallest integer. This x is what, your smallest integer. This x is what, your smallest integer. By multiplying that integer, we have to make all these integral value. Okay, and these are, you can see that these values are already what, integral values. These values are already what, integral values. Okay, so now the x must be what, 1. So it will be what, a simplest whole number ratio. Simplest whole number ratio will be what, 2, 4 and 1. Okay, I'm just explaining this particular whatever I told you with a more, better example. Just see this. Okay, see this particular example, that suppose you have this mole percentage, moles of the element. Suppose you have this moles of element. Okay, so this is what your moles of element. So if you are getting this moles of element, suppose if you are getting this is what, 3.35. okay, suppose A is there, okay, and some element B is there, okay, and it is what you are getting, what, 0.94. okay, so first you have to find what, simplest ratio. Okay, so you have to find what, simplest molar ratio. So what will be the simplest molar ratio? That is what, simplest molar ratio, SMR. So it will be what I told you, that you have to just pick the smallest value and divide it both by that smallest value. So this is what, 0.35 upon 0.35. okay, so this is what your 1, and this is what is 0.94 upon 0.35. so this value will come around, this value will come what, 2.66. okay, now you have to find what, simplest whole number ratio. Simplest whole number ratio. And for that, what you have to do, as I told you, you have to multiply with this x, that is, x is an integer and this is the lowest and the smallest integer, so that these two becomes what, integral values. So what should be the value? Suppose we take 1, if we take x equals to 1, so 1 into 1 will be what, 1, and 2.66 into 1 will be what, 2.66. So these are not, this one is integral value, but this one is not an integral value. Okay, if suppose we take x equals to 2, so it will be what, 1 into 2, that is equals to 2, and 2.66 into 2. So again this one is what, this one is what, 5 point around, it will be what, 622. So it will be around 5.2, and again this one is not integral value. Okay, so you have to take next integer, and that is what, your x equals to 3. All right, so it is what, 1 into 3 will be what, 3, perfect. And what about 2.66 into 3? So this will becomes what, 8. So now these two values are what, coming integers, so that you have to put this x equals to what, 3, and then you will get what, simplest whole number ratio, that is what, 3 and 8. So hope this you understand this particular concept. And here fortunately these are what, simplest, already are in simplest whole number ratio. Now the next thing is what you have to do, that you have to write the empirical formula. So just I'm writing here empirical formula. It's very simple. So what you have to write, how to write this empirical formula? So just see empirical formula. All right, so what is this, how to write empirical formula? So just see this simplest whole number ratio for carbon. Okay, and just add. So this is what is C2. Then C or hydrogen, it is what H and 4. So it is what C2 H4, and this is what oxygen, it is what 1. So if it is 1, there is no need to write 1. It's self understood that it is 1 is here. Okay, so this is what your empirical formula. Okay, how to find this molecular formula? So to find molecular formula, first we have to find what Z factor. You have to find what Z factor, and that is what is the formula how to find this Z factor. That is what molar mass upon empirical formula, that is EF. That is EF, you can write it like this, EF, empirical formula mass. Okay, so your molar mass is given here, that is what your 88 gram, and find the empirical formula mass. So empirical formula mass will be what 12 into 2 plus 4 into 1 and plus it is what 12, that is your mass. 1 is your mass of hydrogen and the number of hydrogen is 4, and then again what is the mass of oxygen? It is what 16, and number of oxygen is what 1. So when you will calculate, you will get to that it is what 44 grams. So this 44 gram is your what empirical formula mass. All right, so put it here, 44 gram. So your Z factor become it is coming what 2. So your Z factor is 2. Now how to write this molecular formula with the help of the empirical formula and your Z factor? So it's pretty simple. Empirical formula, you have empirical formula and put Z factor here. Put Z factor here. Okay, so this is what your empirical formula was, what C2H4O, and your Z factor is what 2. What you have to do, simple, just you have to multiply with these coefficients. Okay, just you have to multiply with these coefficients, and it is 1. So it will becomes what C4, sorry, it will become what C4, 2 into 2, that is what 4, 2 into 2, that is what your 4. Okay, now it is what your H. So it is what your H4 and into 2. So 4 into 2 will be what 8. All right, and it is what your O is what nothing is there, so 1. So 1 into 2, that will be what O2. So this becomes what your molecular formula. Just I'm giving you, suppose you have empirical formula CH2O and your suppose Z factor is 6. So the molecular formula will be what C6H12, that is 1 into 6, 1 into 6, C6, 2 into 6, it is what 12, and 1 into 6, it is again what C6H12 and O6. So I think hope you understand this concept.